Now, holes in the envelope. The envelope of a house is the outside surfaces. It's the floor, the walls, and the roof. Anything that's contained in that space, that's the living area, is called the envelope of the house. And if that has holes in it, obviously it allows moisture and humidity to transfer back and forth from outside to inside the house. And every time that happens, it causes the house temperatures to change and energy to be used. This infiltration occurs, and these holes are poor seals in doors and windows, gaps at electrical plates, open seams along walls, joints in wall surfaces that are open, drains through the floor that are not sealed, cables that come through the walls and the cabling is not sealed at the penetration in the wall, and then vents that come through the ceiling and the roof. Here's a good example of how you can have a lot of holes in the building. Each one of these is a vent stack that's either for a plumbing device or for a piece of equipment in the house, like a water heater or a furnace, or for some kind of a ventilation system that goes with the house. Every one of these is a hole in the envelope and a place for moisture and heat to transfer through. What we want to do is reduce the numbers of those, and here's how we do it. This is just a diagram that I've just shown a lot of toilets lined up. It doesn't matter what kind of fixtures they are, but what you need to know is that each fixture, whether it's a toilet or a sink or a drinking fountain or a bathtub or a shower, each fixture in your house has got an air stack that comes out, and that's what allows the water to drain properly. The more air stacks that you have, the more holes you have in the roof, and that allows moisture to come in and out of the house and temperature to exchange as well. What we want to do is combine those, and we do that with a device called a manifold, where all of those vents come within the envelope of the house and they join into one stack, and then that one vent vents out through the roof right there. So let's take a look at what happens with this. Remember, each one of these is a hole in the roof, and we want to reduce them. So watch what happens when we just reduce the number of holes in the roof. We can go from this to this. Watch it again. You go from that many stacks on the house to this many, and you can see how many holes are eliminated and how much better energy-wise and infiltration-wise that is for the project. There's another type of hole. It's the entire foundation. It's seldom recognized as a hole because it's the same size as the house. It involves the entire total square footage of concrete in contact with the ground, including basement walls. All of it must be sealed with a capillary footing break. A capillary footing break blocks moisture at the foundation, floor, and edges. In essence, it's a plastic sheet that prevents moisture from going through, and you lay it right underneath the concrete and under the footing, and it goes around and up the side until you get back to ground level. And it prevents moisture from coming through into the concrete and getting into the house, and also prevents heat from being pulled out by the damp, cold ground. On basement walls, it's the same way. It goes underneath the floor and then up the side walls, anything that's in contact with the dirt, and it stops moisture and heat from moving back and forth through the concrete. Here is a diagram of one that's installed incorrectly. The plastic comes as far as the footing and then stops, but energy can still be transferred from the concrete to the dirt that's in contact with it. Here is a capillary break that's installed correctly. The footing actually runs right here and then right down here, like that. And they've got this covering everything. It actually turns down into the footings and comes back up, and then it's laid out on the ground. Once that concrete slab is poured and those basement walls are built straight up and down, then this plastic will be folded up against the basement wall to prevent the transfer of moisture and heat through those basement walls.